Okay, so random, it says somewhere within there about random. What's the other things we're always looking for? Independent. That's the 10% rule. Okay, do you think that they're talking about 12 hours in a whole week? There's more than 10 times that in the whole week. The trick is, I don't know if this says anything about normal within there. So, let's see. Normally, we want to see that it's 30 or more. Are there 30 samples or more? No. How many samples are there? 12. So a lot of questions from the book now for these T's are saying, do a plot. Plot them and check and see if they're normal. So you already have them in your computer or in your calculator over here. If I were to do a graph of them, if I were to look at a dot plot of them or a histogram, does the data look normal? Okay, from a dot plot, I mean, that looks okay. You could also look at different types of plots. Try a normal probability plot. Does it look linear? Roughly linear. That's what kind of gives you a hint. And we're looking for a loose interpretation, so it can be a little skewed. It can be look like there's a little bit of an outlier, but we want it to be roughly normal. So when you look at something like this kind of looks really actually linear. So I'm going to check off the normal. I'm going to check off the normal by looking at that normal probability plot. So we're allowed to have it below 30 samples or 30 for the count, as long as it looks roughly normal. This is the normal probability plot, and that's showing us that it's normal. So for when we're doing this T, we got to see what we're testing. So look at the wording of this question before we go any further now. What's our HO and what's our HA? 50 minutes is what they're saying. That's their claim, right? We're assuming that's true. If that's true, we've got a mean of 50 minutes. Okay, we're trying to see if they play more commercials than they claim. So that means that they would be playing less music, which would be less than 50. This is not the one where we're going to double it, where we're going to look at the bottom and also look at the top. We only care about the lower end, or the p-value at the end of that. So for a t-value statistic, it's so similar to a z. But remember, the t-curve is a little bit larger. I'm going to write it down. It's x bar minus the mean of the null hypothesis. Remember, technically, this is the mean of O and the mean of A. We kind of leave those out now, but you might want to put it in now so that you can kind of tell the difference between it. The standard deviation of the sample divided by the number in the sample square rooted. So it's very similar to what we were doing for the z. Z was the actual minus the mean over the standard deviation, and all these were related to what the expected score was. So it's very similar to that, but we have to make sure that we're not using the z table at the end, we're using the t table at the end to interpret it. So the sample mean, 47.9, that sounds good, and the S of x. Remember, you can only use lowercase sigma if you know it's the population, and we definitely don't know that's the population, we just know it's a sample. Was this 2.81? Our sample mean minus the mean of what we think it should be, our expected mean, and then we want to make sure that we adjust that standard deviation to include how many subjects we're using, 12 of those. Which is weird because in the T table there is no negative numbers. And this is like 81.81, something like that. Negative 2.59? Yes. Does that sound about right? Okay, so we need our T table, and we're trying to find where it's negative 2.59. But there's only positive numbers in it. What should we do?
Isn't it the opposite of the positive one?
Yeah. Think of if you had negative 2.59, it would be the same as positive 2.59. So there's really not that much of a difference. And the other thing is we need to know degrees of freedom. If we're testing 12 people, 11 is what number we're looking for. So in the table, you want to go over from 11, and you want to go over till you hit about 2.59, and you'll notice something when you do so. So where is it between? When the P is low, reject the ho. Get it? H-O. And it makes me giggle every time because it's kind of naughty, but it just means reject the H-O. But we talked about it before. We said when you get this probability, and it's so small, that there's no way this could possibly happen by chance. There has to be some other reason that this happened. So we're going to use that same sentence we were using before, which was since the P, no, this is a statistical test. So this one was the p-value is smaller than, and we use alpha in there. We reject the null hypothesis. Then we got to put it in context. We can conclude that there is sufficient evidence that they play less than 50 minutes of music per hour on average. Because we want to include that mean within the answer.